the code implementation of this flying stairs in a recursive way. If you haven't reached out to the theory explanation of video, like I have explained this on the pen paper, you just reach out to that video first and then come here. So yeah, I explained you the problem already, right? You are climbing the stairs, it takes n steps to reach at the top. Each time you can either climb one or two steps. So like you can jump from one or you can jump to two. So in how many distinct way you can climb to the top, whatever the n is given. So for the n, like I told you, like you can go to 1 plus 1 or you can now go directly 2. So you have actually n is equals to 2. Means there are total number of 2 ways to reach to the second stair. Similarly for n, you have 3 ways. Like you can go 1, 1, 1, you can go 1 plus 2 or you can go 2 plus 1. So these are 3 ways. Constant is given like the n should be greater than or equals to like 1 to 45, right? So the basic recursive way, like the recursive way is you will have a base condition. Like once you crack the recursion tree, right? Once you have cracked recursion tree on pen paper, it's very easy to write a code. Like code is just a piece of cake for you. So what was our base condition? Like for n equals to 0, it was 0. For n equals to 1, it was 1. For n equals to 2, the answer was 2. So the base condition f n is smaller or equals to 2, then you just need to return n. This will be the answer. Otherwise, you need to call a recursive way of whatever the result of the previous step plus the result of previous to previous step. That's what we have done, right? So yeah, this will give you the result. Yeah, this is accepted. Now we submit it. So basically the answer is correct, like the recursive way is correct, but the time limit is getting executed. That's actually the problem in the recursive approach. The result is fine, but it's taking huge to process it, and that's how the dynamic programming got introduced. So in this scenario, like if you see in my previous example, if you see the recursion tree, there are overlapping problems. So now we'll solve this same problem. We'll include memorization in between. Like we'll see where we are doing the overlaps. We'll save those our overlaps by introducing a memory, and then we will just try to append a memory here into the same program, and we'll call it as a dynamic program. Dynamic program is a very easy thing. If you understood the recursive tree, the overlapping problem, and then how to resolve the overlapping problem by just using the memorization. So in the next lecture we'll do the memorization and we'll introduce the memorization into this solution.